Okay, we're on to our last video in Lecture 5. In this part C, we're going to talk about temperature. And just like everything you run across, there are units for temperature. And in this case, instead of calling them temperature units, we usually call them the temperature scales. So let's move on to that. So there's three temperature scales. All of them are named after people, after scientists. Most of these scientists lived, a while ago, a couple hundred years ago. So the one that you hear in your everyday life, like in the news or whatever, when they tell you it's going to be 85 degrees out, that is Fahrenheit. So Fahrenheit is kind of our everyday temperature scale, named after a German chemist who came up with this scale, Daniel Fahrenheit. Lived in like the 16 and 1700s. Now, when you think about science or maybe other countries, they don't use the Fahrenheit scale. Typically, in science, we're going to either use the Celsius scale. Celsius, again, named after a famous person. It was actually Andreas Celsius. He was a Swedish astronomer, lived roughly around the same time as Mr. Fahrenheit. So we'll use that one sometimes. But actually, the one that we use the most common, the one that actually comes up the most at chemistry class, especially when we get later on this semester, is called the Kelvin scale. So the Kelvin scale was named after another person who came up with a scale, and his name was actually William Thomson, but he was actually British royalty. So he wasn't a duke or a duchess, he was a lord. He was Lord Kelvin, Lord of Kelvin. All right, and he lived a little bit later in the 1800s. So all three of these guys, they came up with scales. They came up with scales that measure how warm something is. Now, when we want to talk about these scales, it would be a good idea to kind of have a feel for how they relate to each other. And that's what I'm going to start off with. Now, eventually, we will learn how to calculate, if you have a temperature in Fahrenheit, how to calculate that temperature in Celsius and so on. But before we get to any of that, let's just look at how these scales roughly correspond. So one way to think about how they roughly correspond is to think about um, where does water boil on these scales and where does water freeze on these scales? So the simplest one is actually Celsius. And the reason for that is Celsius, Mr. Celsius, he set up his scale. It is actually based on the properties of water. Based on the properties of water. So he put a thermometer in boiling water, and wherever the liquid went up to, the temperature he called boiling water, 100 Celsius. And he stuck a thermometer in ice water and freezing water, and wherever the liquid went up to, he called that 0. So his scale is kind of related to water. So 100 is where water boils, 0 is where water freezes. Now, turns out the other scales didn't use water as like kind of their reference points. For Fahrenheit, Fahrenheit used 0 on his scale, actually has to do with salt water. So 0 Celsius, sorry, Fahrenheit, misspoke there. 0 Fahrenheit is where salt water freezes. It's a kind of special kind of salt water. We won't get into all that, but it's where salt water freezes. So as far as regular water goes, though, it freezes at 32 Fahrenheit. So not 0, 32 Fahrenheit. And then water boils at 212 Fahrenheit. So his scale had more to do with the properties of salt water and so on. So regular water, though, freezes at 32. It boils at 212. All right, now what about Mr. Kelvin? So Mr. Kelvin's scale, he said wherever water boils at, I'm going to call that 373 Kelvin. And wherever water freezes at, I'm going to call that 273 Kelvin. So what in the world, what in the physical world does 0 Kelvin correspond to? 0 Kelvin doesn't have to do with where regular water freezes. 0 Kelvin doesn't have to do with where salt water freezes. 0 Kelvin on his scale, oh, let me switch to another color. Well, we'll go with red still. 0 Kelvin on his scale is where molecules stop moving. All right. And that point actually has a name. It's called absolute zero. Absolute zero. So the way nature works is whenever you have a substance, it could be a solid or a liquid or a gas, the little molecules inside of that substance, they're always bouncing around. So they're bouncing around, and it turns out when they get warmer, they bounce around quicker and quicker and quicker. So it's kind of like they're dancing. And when you have a warmer substance, they're dancing faster. And when it's a little colder substance, they dance a little slower. So if we can imagine getting them really, really cold, they slow down and they slow down and they slow down even more. Eventually, there's going to get to be a point where they stop dancing at all. And that point is 0 Kelvin. It's called absolute zero. Okay, with that, let's move on and talk about how to actually convert between these different temperature scales. So the way that we're going to convert between them is it's on that handout that you should have access to. You can download it and print it maybe. The one that says conversion factors, the one that we used in the previous videos. Now, in this part, we're not going to be actually using a conversion factor really. The way that you can convert between temperature scales is using these little equations right here. So it's actually converting with equations. So to make it easier, I'm going to go to the next slide where I just kind of blow up that part, and we'll do some examples where we practice converting between these scales. So let me go ahead and flip over to that. So again, what you're looking at here, this is that conversion factor handout sheet that you can download under this same module. Same one we used last week. I've just focused in on the top part because at the top part, this is where you're going to see how these different temperature scales are related. There's 3 equations. They're right here on the right-hand side. And you'll notice that for each one, it allows you to solve for something different. So this one right here, the one on the left, this is what I would use if I want to solve for Celsius. So it's always easiest mathematically, right? When you have an equation, if the thing you're looking for is all by itself. So if you're looking for a Celsius temperature, you would want to use this one because it's the one where Celsius is all alone on the left-hand side. Now, if we were doing a problem and I wanted to solve for Fahrenheit, the one I'd want to use this one. Because again, Fahrenheit is all by itself on the left-hand side. So that's the one you use to solve for Fahrenheit. And then finally, there's one to solve for Kelvin. So that would be this one down here. So if you're solving for Kelvin, you use this equation. All right, now as far as it goes, you can see that hopefully you have information to put on the other side. You plug it in and whatever temperature you have, and you can solve for temperature in another unit. Now, when we do this, we do have to be a little careful with our math because it's easy to make a math mistake. So let me go ahead and do this first example for you. So it says over here on the problem on the left-hand side, I want to convert 98.6. That's like your normal body temperature, right? If you're healthy, you have a body temperature of about 98.6 Fahrenheit. And I want to convert it to Celsius. I want to convert it to Celsius. So if I want to be able to do that conversion, the way I would get it done is, first off, I got to know which equation I'm going to use. So if you're solving for Celsius, this is going to be the one that you're going to want to use. So I'll go ahead and just start by writing it down. Let me put it over here on the left-hand side. So I'm just copying it from our handout. And I've given you a Fahrenheit temperature, 98.6, normal body temperature. We'll put that in for F, and we'll do our calculations, and hopefully we'll be able to get the temperature in Celsius. So 98.6 goes in here, minus 32, divided by 1.8. Now, I want to remind you or point out something to you. So do you see how that top part is in parentheses? So whenever you have a part of a math problem and it's in parentheses, that means you need to do that part first. So I actually need to subtract 98.6 minus 32 and then divide by 1.8. So the way that you need to do that on your calculator is when you are ready to type this in, you're going to want to do 98.6 minus 32 and tell your calculator to actually do that. So hit equals. So 98.6 minus 32, hit equals. Now just to make sure, let me grab my calculator and I'm going to go ahead and work it out. 98.6 minus 32. I'm going to hit equals. And when I do that, your calculator should say 66.6. And then we're going to divide by 1.8. If you don't hit equals right now, or if you don't get 66.6 and then divide, your math might be a little bit off. Your calculator may not do what you want it to. So I've done this top part. I subtracted. I got 66.6. Now I'll divide by 1.8. If you do it and you do it correctly, the way I would work it out, I would get 37. Now before you're worried, 37, is that the right answer as far as rounding? Well, the way that we're going to round again is basically, the numbers in this equation are like exact values, the 32 and the 1.8. So similar to when we did converting before, if I give you, I guess, 3 sig figs, you're going to give me 3 sig figs. So your calculator right now, if you're following along, might say 37, but you would actually want to write, because that's only 2 sig figs, right? You'd actually want to write 37.0 to give me 3 sig figs, just like I started with. Oh, and we need units there. Oh gosh, we got to have units, Celsius. So it should be 37.0 Celsius. All right, with that, let's try one more. All right, so I'm going to flip over to the next page, and let's do another one. Let's just make sure we're okay. So let's flip over here. And here's another one. So let's say, again, we're going to think about body temperature. And let's say your body temperature is 42.5 Celsius. What's that temperature in Fahrenheit? So now we're starting off with Celsius, 42.5 Celsius. What's that temperature in Fahrenheit? So you've got 3 equations you can use. Now maybe to tell them apart this time, I'm going to label them A, B, or C. So which one would you want to use? A, B, or C if we're solving for Fahrenheit? Okay, you should have picked B. So we're going to use equation B to solve. So for B, the way you would do it is, again, we'll write down the equation. So we're solving for Fahrenheit, so let's go with the one where Fahrenheit is all alone. And then you're going to plug in your Celsius temperature, 1.8 times 42.5 Celsius. That goes in for C, and then you're going to add 32. All right, when you work it out, if you work it out correctly, let's see, again, I'd have to multiply first, and then I would add. This is getting into like order of operations. Usually you do multiplying before adding. So you might remember for order of operations, there was this little acronym, PEMDAS, right? Maybe that sounds familiar. So in the last one, we had to do parenthesis before, what was it? Dividing, I suppose. Now we're doing, well, multiplying before adding. So yeah, you should multiply first. Okay, so we'll do 1.8 times 42.5. When you multiply, you get 76.5, and you still got to add your 32. So when you add your 32, you get, 108. Actually, 109 if I round, because again, this has 3 sig figs, so my calculator is actually saying 108.5. But if I give you 3, every other number in this equation is the exact value, so I should get 3 at the end. I want to end up with 3, so I'd round to 109 actually. 109F. All right, so if your temperature was 42.5 Celsius, that would be the same thing as having a temperature of 109 Fahrenheit. if that was your temperature, converting your temperature to Fahrenheit would be the least of your worries, wouldn't it? Because if you had a temperature of 109, you would actually, you'd be dead, right? So you probably wouldn't be worrying about this. But if you had a temperature that high, or if it was that hot outside, that's 109 Fahrenheit. That's pretty darn hot, isn't it? All right, let's try one last one just to make sure we got this figured out. So one final example. Let me flip over to my last slide and we'll get to that. Okay, one final example. So let's say I wanted you to convert 375 Fahrenheit. So maybe that's like the temperature of your oven, you're baking something tonight or whatever. And I want you to tell me what's that temperature in Kelvin. So if you have 375 Fahrenheit, what is that temperature in Kelvin? So again, just so we can kind of know, I mean, first off, we got to start knowing like which equation is going to help us out. So let me again label them A, and then we'll call this one B, and then we'll label this one C. All right, so if I wanted you to convert from Fahrenheit to Kelvin, and you look at those equations, there isn't one that actually helps you do it directly. There isn't one that goes straight from Fahrenheit, like you have Fahrenheit on one side, and then on the other side, there's Kelvin. So actually, you would actually need to do this in two steps. You're going to have to use one equation, come up with an answer, and then use a different equation, continue on, take that answer, and continue on and use a different equation to get all the way to Kelvin. So what would you want to do? Where do you want to start? What equation would you want to start with first? What equation would you want to start with first? And then what equation would you have to use after that? Think about it, think about it. Okay, the only way of getting it done is you're going to have to start off with equation A. Take your Fahrenheit temperature, convert it to Celsius. Once you get your answer in Celsius, then you can use that answer and go from Celsius to Kelvin. All right, so it actually is going to take two steps. Get me to Celsius, and then once you get me to Celsius, you can get me to Kelvin. It's going to take two steps. So let's go ahead and work it out. Let's see if we can get the right answer here. So I know Celsius is Fahrenheit minus 32 divided by 1.8. So I'll go ahead and put in the 375 for my Fahrenheit temperature. I'm going to subtract 32. Now again, when you use this one, make sure you subtract first, hit the equal sign, then you'll divide by 1.8. If you work it out correctly, let me go ahead and do it. 375 minus 32 equals, and now divide by 1.8, because you got to subtract first. That is, again, I'm going to round 191 Celsius, 191 Celsius. Oh, did he round that right? I think so. I gave you 3 sig figs. This number has 3 sig figs. So yeah, we're doing okay with the rounding. All right, so everything else in the equation is an exact value. All right, now what I would do is I would take that answer and I'd have to keep on going because I want to know Kelvin, don't I? So I would, to get to Kelvin, I would take my answer I just came up with, 191 Celsius, add 273, and you got Kelvin. So I'm using equation C right now. Take that Celsius answer, get me to Kelvin. And if you work it out, 191 plus 273 equals 464 Kelvin. All right. So only other thing I want to point out to you, because I get this question all the time. For Kelvin, there is no degree sign. It's not degrees Kelvin, it's just Kelvin. There's a reason for that I'm not going to get into. So when we use Celsius, yeah, it's degrees Celsius. When we use Fahrenheit, yeah, it's degrees Fahrenheit. But for Kelvin, there's no little zero in the corner there. It's just a K. All right, I hope that makes sense as far as how to convert between all these different temperature units. If it doesn't, of course, you can contact me or ask me some questions in our office hours. I'll be glad to help you out. Email, phone, whatever works for you, it works for me. All right, so we're done with this part of our lecture. And actually, this will be the last lecture in this set. So you're done with lecture, I think we're on 5, aren't we? Whatever it is, we're done with it. And so we'll stop for this series right here. Bye-bye.